Section 2 is about how to measure simple harmonic motion. We will learn some terms. First term which we are going to learn is amplitude. What is amplitude? So amplitude's definition in the book is given like this. The maximum displacement from equilibrium position is called amplitude and represented by capital A. So till now we talked about the maximum displacement. Remember in the previous explanation, this is, for example, maximum displacement. In simple pendulum, this maximum displacement is generally represented by angle. So, but in mass spring system, that maximum displacement is represented by distance. So mass spring systems, amplitude is the maximum amount of stretching or maximum amount of compression. If it is maximum amount of stretching in here, it is positive A. If it is maximum amount of compression, so negative A, but will be represented by A. In mass spring systems, amplitude is maximum amount of stretching or maximum amount of compression. But in simple pendulum, so this amplitude is measured by angle, mostly with angle, also with distance. When it says the angle, this is the angle. For example, on the right side of the equilibrium position, this is positive A. On the left side is this is negative A with the angle. But also your book is adding this distance. When it talks about distance, talking about that arc length. But this is not a very usual way in physics books they are using. They don't use this, but your book, as I said, is added this one. Is pendulum's amplitude is measured by angle and mostly with angle, but also by distance. It is also possible if you prefer it. And this is positive A, as I said, positive A, theta maximum is positive A. Negative theta maximum is negative A. Next one is we will define what one cycle is. Cycle, circle. So they are coming from the same root. Circle, cycle. Swinging from maximum displacement on one side of the equilibrium to maximum displacement on the other side and then back again is considered to be one complete cycle. Definition clearly explains what one cycle is. So swing, you are going to swing from maximum displacement on one side. For example, initially I am here, assume that. I will swing from this maximum displacement to maximum displacement on the other side. On the other side, this is the maximum displacement on the other side, but you are not going to stay there, then back again. So you will come back again to where you started. So this is known as one complete cycle of vibration, one complete cycle of motion. Okay, during this one complete cycle, this vibrating object travels a distance which is equal to 4 times amplitude. Why? Because one amplitude is from positive A to 0. Distance traveled is 1 amplitude. From 0 to negative A, 1 more amplitude. From negative A to back to 0, 1 more amplitude. And from 0 to positive A, 1 more amplitude. Add them all, A plus A plus A plus A is equal to 4A. For that, as in a vibrating system, a vibrating object travels a distance which is equal to 4 times of an amplitude for one complete cycle of motion. But displacement of the object is 0. Why? Because object will return to the position from which it started. So in here I started from positive A, go to negative A, and back again to positive A. So where am I again? At the same position. So if you are at the same position, if your final and initial positions are the same, net displacement is 0. So in here you are going to see as animation. I prepared an animation. This object will start from positive A, will go to negative A, back again positive A. This is one complete cycle. from positive A to negative A and back again to positive A. One complete cycle. Distance traveled by during one complete cycle is 4 times of amplitude, but net displacement is 0. No matter from where you start. If you start from positive A to negative A and back to the positive, pardon, this is not positive, this is negative, sorry. If you start from negative A to positive A and back again to negative A, again, distance traveled is 4A, again, net displacement is 0. Even you can start from any other position. For example, assume that you start watching this object while it is in equilibrium position. So it's also possible. Now in here, this object will start vibrating from equilibrium position. So it will go to negative A, back to 0, then positive A and back again 0. This is also one complete cycle. So let's measure it. 1A from 0 to negative A. From 0 to, negative A to 0, one more A. From 0 to positive A, one more A. From A to 0, again, one more A. So this is also one complete cycle. Again, object returns to the position it started. Yani net displacement for one complete cycle. We don't care from which point object starts. Always 0. Distance traveled by the object is always equal to 4 times of amplitude. Okay, now half cycle. One complete cycle is made up of 2 half cycles and 4 quarter cycles. So this is half cycle from positive A to negative A, one half cycle. Or from negative A to positive A, it is another half cycle. So this is another half cycle. So as you see, one complete cycle is made up of 2 half cycles. What is distance traveled by the mass, vibrating mass in half cycle? It is 2A. 1A is from positive A to 0, it is 1A. From 0 to negative A, one more A. For that reason, distance traveled by the mass is 2A. You can see this by animation. This is half cycle from positive to negative A. This is half cycle. But we cannot say that exactly what the displacement is. If object starts from positive A to negative A, this is half cycle, displacement, magnitude of the displacement is 2A. However, if object starts from 0, so net displacement will be different. Now look at here. If object starts from 0, goes to negative A, 1A, back to the 0 again, 2A, object is where it started. For that reason, we cannot say absolutely net displacement is 0. Net displacement can change from where the object started, but distance is always 2A. 1 from 0 to negative A, 1 negative A to 0, it is one more A. Distance for half cycle is 2A, but displacement can change from where the object is started. I didn't write anything about displacement in this part. But quarter cycle is this one from negative A to 0 is 1 quarter. So distance traveled by the object is 1A, or from 0 to positive A, another quarter. So distance traveled is A. From A to 0, another quarter. From 0 to negative A, one more quarter. There are 4 quarters in one cycle. So of course, distance traveled by the mass is A. Again, displacement, I cannot say absolutely displacement is 0 or this one. Again, displacement can change from where you start watching the vibration, from positive A, from 0, or any this point between these 2 points. So for that, as in displacement can change. I didn't write anything about the displacement for a half cycle and for quarter cycles, but we know about the distance. Distance is more important. In quarter cycle, distance traveled is always a. In half cycle, distance traveled by the object is 2a. In one full cycle, distance traveled by the object is always equal to 4 times amplitude. Any questions about half cycle and quarter cycles?
Teacher, why for second one displacement like it changed?
For you mean quarter cycle?
Yes.
I didn't show it, but for example, say that it is from negative a to, for 0 to negative a, displacement is 1a, correct? But if object starts from here, for example, a over 2, 1a over 2, so where is the object? Object is at the point where it started, is it?
Yes.
So net displacement is 0 in this case for 1 quarter.
Thank you.
So this can change. Yani quarter cycles, for quarter cycles or half cycles, we cannot talk absolutely a definite result about the displacement. But for one cycle, we can say, for one cycle, net displacement is always 0. We don't care from which point object starts.
I got it. Thank you.
And other term which we are going to study is period. What is period? Period is represented by capital T. It's a kind of time. It is time it takes for one complete cycle of motion. Yani in how many seconds an object vibrates for one cycle, one complete cycle, that time is called period. Yani object, for example, let's get the definition of the cycle. Object will start from maximum displacement in one side to the maximum displacement to the other and back again. This is one cycle. So how long does it take for this one cycle? That time is known as the period of this vibration. After the time of one period, object is back where it started. So object started from positive A. After a time which is equal to one period, it turns back to the point where it started. I tried to make an animation again, simulation. So this object will vibrate from positive A to negative A and back to the positive A again. Just under this animation, I hope you are going to see a counter. So I want you to measure the time for one complete cycle, period of this vibration. So start. Almost 5 seconds. Almost 5 seconds. That is the time for one complete cycle. It is the period of this vibration. Time for one complete cycle is 1 period. What about half cycle? So it must be half of the period, yani T over 2. Time for one half cycle is T over 2. What about time for quarter cycle? It is T over 4. So this is time from here to there. Yani if an object vibrates from negative A to 0, time it takes to reach from negative A to 0 is T over 4. From 0 to positive A, T over 4. From positive A to 0, T over 4. From 0 to negative A, T over 4. How many T over 4s are there? 4. 4 times T over 4 is equal to what? 1T. It is time for one complete cycle. So that's why we should know this. Time for half cycle is T over 2. Time for quarter cycles is T over 4. If 10 cycles take 30 seconds, what is the period of this motion? So there is an equation you can use. Period can be calculated by total time divided by number of cycles. What is total time in here? 30 seconds. Write 30 in here. How many number of cycles are there? 10 cycles. Write it in here. 30 divided by 10 is 3 seconds. So these vibrations one cycle is completed in a time which is equal to 3 seconds. Or you can use cross product. So you are going to write something like this. If 10 cycles take 30 seconds, so one cycle takes how many seconds? It's called period. Time for one cycle, it's called period, T. Cross product, so which means T times 10 is equal to 1 times 30. Divide by 10, divide by 10, simplify 10, T is equal to 3 seconds. So if you don't remember this equation, you can do it on your own by using definition of period. So 10 cycle takes 30 seconds. This is from the question, but this is definition. Second sentence is definition. One cycle takes T seconds, which is the period. Time for one cycle is 1 period. After that, cross product. T times 10 is equal to 1 times 30. Then T is 3 seconds. And now frequency. What is frequency? Period and frequency are reverse things. In period, we are measuring time for one cycle, but in frequency, we will measure number of cycles in 1 second. So frequency definition, number of complete cycles of the mass swings in a unit time. That unit time is 1 second. In 1 second is called frequency of this vibration and represented by F. F is the symbol of frequency. Frequency is calculated in reverse way of period. So remember, period is total time divided by number of cycles, but frequency is number of cycles divided by total time. So for that, its unit is 1/2 because time has a unit second. Number of cycles has no unit, it's just a number. So 1/2 is the unit of frequency, or sometimes this 1/2 is written like this, second power of -1, or given a name of the scientist, one of the popular scientists, Hertz. Hertz is also unit of frequency. For example, if 10 cycle takes in 1 second, in 1 second, how many cycles are there? 10 cycles. So number of cycles in 1 second is called what? Frequency. Frequency is how much? 10. So if there are 10 cycles in 1 second, then you can say that frequency of this vibration is 10 Hertz. How many cycles are there in 1 second is defining the frequency. Now I'm going to try to show a simulation again. The above object will vibrate 5 times. So in how many seconds it vibrates the 5 times? I want you to count it. So start 1, 2, 3, 4, and 5. 11.6. So 5 cycles take 11.6 seconds. So question is that in 1 second, how many cycles are defining the frequency? In 1 second, how many cycles defining the frequency? Cross product. So F multiplied by 11.6 is equal to 1 multiplied by 5. Divide by 11.6, divide by 11.6. So result is, let me have my calculator. 5 divided by 11.6, which is equal to 0.43 Hertz. Or also you can use this equation. What is this equation tells you? Number of cycles divided by total time. How many cycles are there? 5. What is time for these 5 cycles? 11.6. 5 over 11.6, 0.43 Hertz is the frequency of this vibration. And questions. If 10 complete cycles takes 5 seconds, what is frequency of this vibration? equation, let's use equation. Number of cycles divided by total time will give us the frequency of this vibration. There are 10 complete cycles. In how many seconds? In 5 seconds. So frequency is 2 Hertz for this question. Another question, another one. If it says that one complete cycle takes in 20 seconds. One complete cycle takes 20 seconds. What is frequency of this vibration? Again, this time let's use the definition of the frequency. So in 20 seconds, there is one cycle. In 1 second, there is F cycle, because it's the frequency definition. In 1 second, number of cycles in 1 second is frequency. Cross product, F times 20 is equal to 1 times 1, divide by 20, or divide by 20. So F is equal to 1 over 20, which is equal to 0.05 Hertz. Or just you can use the previous equation. Number of cycles, one cycle. In how many seconds? 20 seconds. 1 over 20 again, 0.05 Hertz. So this is how we can calculate. We calculate the frequency of a vibration. But as I said, frequency and period are inversely related, because period is calculated by, for a vibrating object, period is calculated by total time divided by number of cycles. But frequency is calculated by number of cycles divided by total time. If I multiply frequency and period of a vibrating object, so you are going to see that these total times will simplify, number of cycles will simplify, result will be 1. For that, if you multiply frequency and period of a vibrating object, you will get always 1. So result is going to be 1. That's why you can write this equation in 2 alternative form. One of them is frequency is equal to 1 over t. Other one is period is equal to 1 over frequency. Say that period of an object is given 2 seconds. Frequency will be 1 over 2. Say that frequency is given 4 Hertz. Period is going to be 1 over 4 seconds. So they are always inversely proportional. If one of them is 2, and the other one is 1 over n. If one of them is 3, the other one is 1 over 3, and so on. And one of the sectional question, also ministry exam question. So by the time you will learn what metronome is, the reading on a metronome indicates the number of oscillations per minute. What are the period and frequency of the metronome's vibration when the metronome is set at 180? This is a metronome. Generally, musicians are using to make tempo with this device. So you can, if you are going to play a slow music, you make this metronome vibrating at a smaller rate. If you are going to play a faster, a quick music, so you are going to make this metronome vibrating quicker. So reading of the metronome indicates number of oscillations per minute in 1 minute. Yes, this is total time. Delta T is 1 minute. How many seconds? 60 seconds. What are the period and frequency of the metronome's vibration? When the metronome is set 180 vibrations. So this is number of cycles or number of vibrations. It is 180. So then calculate the period and frequency of the metronome's vibration. Let's get the period first. We know that period is equal to total time divided by number of vibrations or cycles. So total time is 60 seconds, because question gave this answer, divided by a number of cycles. number of vibrations in this 60 seconds is how much? 1 minute 180. So it is 60 divided by 180 is 1/3. 1/3 seconds is the period of this vibration. If period is 1/3, what is frequency? It's going to be 3, because we know that frequency and period are inversely related. So we can say that F is equal to 1/T, 1/3, which is the period. Flip 1/3, it becomes 1 multiplied by 3/1, which is 3 hertz. Or directly you can say that if one of them is 1/3, other one will be 3. So frequency will be 3 hertz. Period of this vibrating metronome will be 1/3 seconds.